Hello, my name is Oscar. Welcome in the new video series on how to use the key functions of engineering tool GX Works 3. In this very first episode, we will start with simple CPU communication function. This is probably one of the easiest ways to exchange data between two devices. The idea is based on the direct exchange of registers value. And here it is why we call it simple. There is no any programming required, only the quick configuration on our PLC side. You don't have to make any changes on the target device. So it's perfect solution, for example, to collect data from existing systems or machines. Today, we will cover three scenarios. The first one will be communication between two IQF, so-called FX5 PLCs. Then, we will connect IQF PLC with the Modbus TCP server. And the last example will be communication with Siemens S7 series PLC. In all of these cases, we will be using the same IQF PLC and its integrated Ethernet port. So let's jump into software. So we open GX Works 3 and create the new project for FX5 CPU. When the project is made, we look for the parameter section in navigation menu and then FX5 CPU, module parameter and Ethernet port. In the new window, we open application settings and choose simple CPU communication. In the first field, we have to enable the function, so we choose use. And then we can go into detailed settings. Let's make some more space here. And we can start with the read function. Let's leave the communication interval for the 100 milliseconds for now, and we have to specify the source of our data. In this example, we will be reading data from another IQF PLC, so we have to specify just the IP address. And then we have to choose what data we want to read. The first will be the bit data type. For this, we are using the M registers. So we will be reading the registers from 0 to 15 from our source PLC. And we want to store this data on our PLC, also on the M registers, let's say from 64 to 79. It's calculated automatically. In case of word data type, we will be using the D registers. So let's read registers from 0 to 10 and store them on our destination PLC on the registers D100 to 110. Now we can continue with the write function. In this case, we are the source of data, so we have to specify the destination. And it's again the IQF PLC. So we specify just the IP address. And again, we choose data we want to write. So start with the bit data from registers M128 to 143 and we write them on the M registers of our destination PLC, let's say 256 to 271. For the word data type, we are using D registers again, let's say 50 to 60. And we want to store them, to write them into the 200 to 210. Now we have to click apply before we write our project to the PLC. Now we can click write to PLC. Now it's time to connect two IQF PLCs together, write our project to one of them and see if our communication is working properly. Okay, on the left hand side you can see the PLC that we configured, and on the right side you can see our target device. So let's start with testing the read function. we will be using registers that we configured to read on. It's M64 and D100, and we are reading from registers on the target device, which are M0 and D0. Let's force some values on the target device to check if it's work. As you can see, both values are already on our PLC, so everything works correctly. Now let's check write function. We will be writing data from M128 and D50 and two registers on our target PLC M256 and D200. Let's force some values again, and we can see that those values are written to our target PLC, so it's working. Okay, now let's read some data from Modbus TCP server. So again, we choose read, but in this case, as a source, we choose device type of Modbus TCP device. In case of Modbus TCP, we specify IP address, but we also have to put the port number. In case of Modbus TCP devices, the bit values are stored on coils. So let's read some example coils, addresses, and we will store this data again on the M registers on our side from, let's say, 0 to 15 in this case, automatically. Word values are stored on the holding registers in Modbus TCP communication. So let's read holding register from 0 to 1 and store this data on D registers from 0 to 1. Communication with Siemens S7 PLC is pretty similar, so we choose read again. In this case, device type is Siemens S7 series, and we have to put the IP address and port number again. In case of Siemens S7 PLC, the bit values can be found under addresses I, let's say I0 to I1. And we can read this data and store on the M registers from 16 to 31 in this case, because under every I address we can find 8-bit values. In case of word values, they can be found on data blocks, let's say from 1000 to 1001. And we can store the whole word data type on the one register, so let's choose, for example, 50. Always remember to click apply before you write your project into PLC. So today we practiced communication between two IQF devices. We also know how to exchange data with Modbus TCP server and with Siemens S7 PLC. I think it's all for today, so thank you for watching and see you in the next episode. Bye!